For problem 8, we have a situation where we have to find what the maximum height is with these dimensions. So the problem is set up as if you have a box and you have to fold in the sides to make the box. Or you have a square and you have to fold in the sides to make the box. Now, the sides, because of the square, they're all the same length. So therefore, the length we found out is y minus, the length is 3 minus 2x. Then the height, because it is just x. So the way we find out what the volume is volume equals 3 minus 2x squared times x, because you're multiplying the base times the height times the width.
And since it was 3 and we took off the x, the base and the x and y are 3 minus 2x, and now the height is x, that part that we took off right there.
So now what we can do is we can split up the 3 minus 2x, so we can do v equals 3 minus 2x times 3 minus 2x times x. Now, that all factors into v equals x, parentheses, 9 minus 12x plus 4x squared. Now we can substitute in the x and we get 9x minus 12x squared plus 4x cubed. Now, the way we find the maximum and minimum values in critical numbers is we use the v prime.
And when it equals 0, that is when it is at the max or min. Or we can see it when it's undefined. But clearly by this, you see that it can never be undefined. And now, so let's find v prime.
Let's find v prime.
Equals
So
9 minus
24x plus 12x squared. Because we
did the
okay. We all know how to do that. So now what we can do is set that equal to 0.
So let's take out a 3 first.
Yep.
Let's take out a 3. So we have 4x squared plus 8x minus 3. This looks pretty good to me. Now let's make that equal 0, and we can factor it out to 2x minus 3 times 2x minus 1. Now, x equals 3 halves, the equation will be 0, or x equals 1 half.
So then we set up our number line. So, because Saman made a bad mistake, we have to scroll down a little bit more.
It's not a mistake.
Okay, so
Let's make the number line, dude.
Yep, let's make the number line, dude. Alright, so we set up the number line, put our critical values, which are 1.5 and 0.5 on there. So I just want to write that. Now draw a hash mark where they are. Okay, so let's plug in a value. Let's say we plug in 2 to the original equation. What do you think you'd get, Simon?
Looks like 2 times 2 is 4 minus 3. A positive times a positive, so I'm looking positive.
Yeah, that's right. No.
How about you plug in like 1?
Yeah, what would you get?
A negative times a positive, which is a negative.
Yep. And what about if you plug in, let's say 0 perhaps?
A positive, I say.
Yep, so now we know that the max is at half and the minimum is at 3 halves. So therefore, our maximum volume is when x equals half. So the way we find out what this volume is by plugging in x into the original equation. So let's do that, Simon.
Okay, so let's plug it in.
So 3 minus 2 times half is 1. 3 minus 2 times half is 1. So what we do, because the original equation is v equals 3 minus 2x squared, so now we can plug in the 1.
Whoa, why?
Times 1, or sorry, 1 half.
Yeah.
That's what I meant. See, this time I messed up some, but you usually do the messing up. Alright, so now we get v because 3 minus 2 times 0.5 is 1. 1 squared times 0.5
is 0.5.
Are you kidding?
Okay, no. 3 minus 2
times 0.5
is 3 minus 1.
Yeah, sorry about that.
2
we
squared is 4.
We have a little distraction
2. The
here.
answer is 2.
Yep, the answer is 2 because Brian is a little distraction today.
And we're looking for the max.
Yep. So. So therefore, the volume equals
2 feet cubed.
2 feet cubed.
We apologize for the distractions, but I hope you were listening and you enjoyed the video. And we'll do well in the test. Thank you. Come again.
Are you sure we will? I don't know about